Okay folks, so we're back again with the SparkFun Inventors kit. We're working on Project B. We've got circuit 3B distance sensor. This is my setup, so new items are the ultrasonic sensor here. So like I think juice energy comes out of this block at the top and goes like whoa, 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 and like bounces off whatever the object is in range and comes back and gets read by these two devices, which allows it to sense to the left or to the right as well as proximity, right? Because you've got the bifocal sensors. So we've got our RGB here, we've got our our resistors, and we've got our wires. Oh, there was one wire that I forgot to set up. Is it just, oh man. Oh, okay. Let's go like this. Let's use, it's supposed to be purple, but we don't have a purple color, so the one color we haven't used on this board is yellow, or white. Okay, so this one goes from here, from your echo. This is your echo on your ultrasonic, and the echo goes to pin 12, like this. Alright. Okay, there we go. So we've got our sensor up here, we've got our light right here. So just what exactly are we gonna expect when we plug this thing in? Okay, so it's gonna give us a green, yellow, red. So traffic lights. It's gonna give us traffic lights out of the LED based on the proximity of the object. Okay, very good. Now we still have the old servo programming in here, so it does not appear to be having any effect on the current circuitry. Let's get the right program loaded up in here. All right. Ooh, this is a big long one, folks. Let's get into some diagnostics here. Okay, so we've got a bunch of variables. Okay, so these are your digitals, these are your analogs. I think. No, they're all digitals. So they're all digitals. So this is... Okay, so these are both connected to the sonic sensor, and these ones are connected to your LED. Okay, so this is just a variable declaration that will later be used to determine object distance. So my guess is that this trigger pin represents this piece here, whereas your echo pins probably represent probably represent your these guys, your drums, these ones. So let's continue on with the diagnostics here. Okay, so here we're telling it to talk to the to the computer. Here we're telling the trig pin. So we're telling it that, okay, so 11. Okay, so whatever. Anyways, this one actually is the driver, I think. And then this one is the measurer. Output. I don't know, I guess we'll find out. I could always read up more on the parts, but that'll be later on. Okay. Yes, that's fine. Yes. Okay, okay. So the action is, okay, so we run the get distance, so that's this function down here. So the get distance says, okay, declaring some vars. Oh boy, wow. Okay, so we output micro, low, okay, so this is a constant that exists inside the circuitry. Okay, well, okay, so here it identifies the distance in whatever unit it reads. My guess is that it's this 148. I think I remember that this thing has a range of 4 meters. So let's go like this. So that's, okay, so this is almost 1 unit per inch. That's kind of I mean, it's off because 1 inch is this many inches per meter, but this is almost the rate of 1 unit per inch over 4 meters. So this could be, so we'll test this with my hand, but here's the hypothesis. This represents 10 inches. This represents 10 to 20 inches. And this represents further than 10 inches. So if we're further than 20 inches, sorry, if we're further than 20 inches, we should see a green light, so no obstacle. If we're at 10 to 20, we have an obstacle imminent and we'll get a yellow light. If we're at 10 inches or less, we'll get a red light. So that's the hypothesis based on the observation of this and the known range of 4 meters and general diagnosis of this code. So let's just validate it and see how this plays out. Okay, looks like we're good. So let's watch out for that yellow light. Should be right here. Yep. Let's look for that console too. Oh, and it does read it in inches. Crazy. Okay, so for those of you guys that don't know, like the keyboard is right here and this is about 4 inches, okay? So let me put my hand here at 1 inch. Yeah, so that's you know, we're talking about like 2 inches and we've got red. So I'm gonna point this up to the ceiling, which is about 4 feet away, and we should get a green light, but we should flash to yellow as this hits the computer monitor, which, you know, you can see my elbow there and my hand is touching the computer monitor. So the computer monitor should produce a yellow light. So let's try that. We're moving up to, so this is that's the computer monitor now that it's sensing at roughly around yellow. And then as we move up to the ceiling, you can see that we get a green light. So again, this is pointing directly up at the ceiling where there's in excess of a meter, so maybe let's call it 50 inches. Oh, and it's actually showing up there on the console. Guys, I was not looking at this. This was just coincidence, okay? So this is a very accurate sensor, I would say. I'm much more impressed with this than I am with the servo. So I'm gonna put my elbow up here and put my hand in the way and see if I can get it to read. So I am in fact producing some yellow lights, and like you can see that, like, that's roughly where I'm waving my hand around. So okay, so here we've got 3, 10. It's hard to stay in the line of the thing, you know. Oh, I'm not sure if you guys can see the full range of colors there. Let's see if I can get some action this way. So we've got like 10 inches here, and we've got the yellow light. So if I move it in, we should get the red light. Yeah, see, there's your red. So move it out here, we've got your yellow. Move it out beyond 20. Beyond 20. Oh, see, it's hard to keep it in the, like, it's really precise. Like, it's really, oh, I'm gonna use the book here. So, for example, there. See, so, oh, see, even here, like, okay. Anyways, yeah, so there's your green. And again, so here going all the way across the room, you know, we're looking at almost the full range. I'm going to back up here and see if I can hit the full range. Alright, so this will definitely require more experimentation, but these are very interesting behaviors and results. It's been a very good project. Thank you very much for tuning in.